Uncle Ron and stuff. This is uh, episode 23. And today, this stuff is some of my history and early computers, programming. Um, yeah, you're going to be a problem, aren't you? That turned it off. Before, before it passes into one of these will turn it off. Yeah, before it passes into history and lost and forgotten, I thought I would throw out some of my experiences because I was relatively early in the use of computers and uh, historical. I thought it was interesting. I went to the Science and Tech Museum, I think in Washington. Took my kids or something, and there on display was a very identical looking sort of IBM personal computer that I had, and it was already in a museum. So I'm like a walking antique, and so I thought I would give you some what it was like back in the day. You know, I used to have to walk 40 miles to school through blizzard storms and all. That's that sort of thing. It's not a brag. It's just making you aware. There's a lot of people programming today and playing with computers, and they do a lot of amazing stuff. And there's a whole realm that I don't know anything about. Never had to try to do anything in that realm, so I don't know about it. But I think the basics are, you know, the mindset associated with it probably still the same. And as a side note, I kind of think it's interesting that our brains seem to be seem to work well in the logic, just logic domain of rules that are in programming languages. There's all sorts of, it's like Lincoln Logs, Tinker Toys, uh, erector sets, which nobody ever remembers, but there used to be metal sort of versions of things that you could put together and make towers and working, metal machines, I guess. Some of them came with motors. Anyway, that building blocks, if you had these blocks, you could build other stuff out of the basic blocks. And the whole idea of a machine which could be programmed and via inputs that went back a ways, and uh, I won't get into that concept. I probably couldn't have come up. I wouldn't have invented that. I was really just an engineer, and all I did was take the tools that were available and do something with them. I didn't necessarily invent the tools, and that's a difference, whatever. Anyway, when I went to college, I graduated in 1969, and I was an electrical engineer. And at the time, I was in a small school, so it didn't have the variety of courses that you would find at a larger school or, say, MIT, which probably had really advanced all sorts of stuff. But at that time, electrical engineering was basically analog circuits. Analog being, capacitors, resistors, not so much vacuum tubes. We had vacuum tube. I learned about them, but by and large, we wound up, if you will, okay. Homework was design a power supply, things like that, and we learned about motors and phasings and all kinds of analog sort of stuff, and really nothing about we even did an analog computer, which was really weird, and you could program it to like model the bounce of the front strut on your car or a shock absorber, that sort of thing. It was not in a. It was an analog computer, which I assume they still have, but I don't know anything about it. Anyway, there was a course offered. I think in I don't know. I didn't get to it till like the junior or senior year. I don't know which one. And the small school had an IBM 1420 or 1620. I think that's what it was, uh, which had an operator. And at that particular time, you had to submit your program on punch cards. Each instruction on what you wanted the computer to do was you had blank cards. You went to like a teletype machine where you typed in, and it would punch holes in this card, and then after you got your program written, you would take it to the service desk, and they would then eventually take it over and read it into a card reader that then entered that program into the computer, and then it ran for, and it it basically consumed the computer. Nothing else could be done while it ran your program. They were single CPU computers in those days. They didn't have multiple CPUs. I did run across a couple times later on where mainframes had two CPUs, and that was kind of unusual. Mainly, it was still only one CPU, and one program ran at a time, uh, which is entirely different from today. Even your PC has multiple CPUs in it, and the programs you run can all run at the same time in different memory space that you allocate to it, and so on and so on and so on. But back in those days, it was on cardboard cards, punch cards, and one program at a time. And anyway, the language that I first used was Fortran, and there are a lot of high. They were known as higher level languages. Uh, I had a job at the Naval Research Laboratory, and it was the Naval Research Laboratory where they had these scientists, or yeah, they were scientists, and they'd have an idea about something, and they would get funded to try to explore it, and they would have enough funding, real basic amount of funding to start with, to prove some principles. And so, usually, in several cases, working there, uh, very small computers. Uh, they didn't have a lot of memory. They had no hard drive. Computers originally had no hard drives at all. All they had was memory, and some of the first computers I worked on had what was called core memory, which had which was a box, and there were little magnetic cores in there like donuts, and wires ran through them, and depending on the way the wire, what kind of current went sent through the wire, it would make that core become a one or a zero. It had a charge or it didn't. And that's how stuff was stored at the time. There were also, at that particular time, a lot of use of magnetic tape, big reel-to-reel sort of tape systems, and those were like hard drive. You stored data that you needed for some period of time on reel-to-reel tape. Now, IBM, somewhere in that period, in the 60s, I don't know, they came out with first hard drives, which are like we use today, only they were huge. They hadn't perfected the whole um, laying of a magnetic film or the metal that hold, the very small ones and zeros stored on a magnetic surface, and how you store them and retrieve them. But they had, I happened to go to the vice president's residence in D.C. because the Navy maintained a telescope there, and they had an IBM computer there to process some data that from observational data, and they had this giant rack of IBM disk drives, and each one held like a megabyte, and the platters were 12 inches in diameter. You pulled a platter out 1 megabyte at a time, or some such small number, and the thing was huge and probably weighed 10, 15 pounds. I don't know, something like that. That was that was old at the time. They had made much advancement on that already, but they were still using it. And they also had magnetic tape, and you ran into big banks of magnetic tape all over the place. I interviewed for a job at one of the colleges, a pretty good sized college, and it was for their data processing center. And when I walked in there, they had a few large uh, hard drive units, and they were like size of a portable refrigerator or something like that. One of those campus type refrigerators that people use when they're in college. It was about that size or a little bigger, but they also had banks and banks and banks of magnetic tape, reel-to-reel machines. And somebody had the job of loading those tapes and unloading them all the time. That's where data was stored. So anyway, there was old hardware. The technology had not advanced very far, and uh, in the NRL work, I was always stuck with a very what had happened during the period when computers were all mainframes at one time, very large machines that only the government had and large corporations. And really, the first use was all for accounting, keeping track of money, of course. And I think the Census Bureau, they were one of the early adopters. And anyway, the government was an early adopter of computers and forward thinking in that way. And they were all huge installations, had to be air conditioned and put in a separate space. And you had to have a lot of operators and magnetic tape units all over the place, and disk drives were huge and all that. But about that time, what was called mini computers came around, and these were small packages. Maybe I don't know, they were bigger than a good-sized cardboard box, but nonetheless, it was a central processing unit, some amount of memory, and then early on, as you probably know, the permanent storage, if you want to call that, was floppy disks, and that was so the first mini computers I worked on, that they didn't have any kind of offline storage at all. You basically had to, the very first ones, if you will, there were toggle switches on the front. And I don't know if you've ever seen any of those, but they had toggle switches, and when you went in the morning and the computer was dead, the first thing you had to do was you had to use those switches to toggle in what was called a bootstrap loader. And once that was toggled in, then it would you could feed in via paper tape. Paper tape was used a lot besides punch cards. I guess it came along afterwards. I don't know. Paper tape allowed you to put, giant program on, I don't know, 50 feet of punch tape. And so you could load it into the reader and it would read the whole program in at one time. So anyway, Early computers, you had a finger bone in what was called a bootstrap loader, and then you had to take your actual program, the want to call it operating system, if you want to call it that, wasn't much above basic stuff, and then you could proceed to load a real program in on top of that that would allow you to use the hardware. The CPU could do things for you. It was programmable in that sense that it would execute various instructions and so on. But to get to that level where you could actually tell the computer what to do, you had to first prime it up. You had to start it up. You had to load in the bootstrap loader. Computers still have bootstrap loaders that is built into the BIOS of the system, and it comes up automatically. You don't even know that you just had to do that. Uh, I often put computer parts together and it's dead like Frankenstein. It's laying there on the table. And then I have to load in some software and try to get it to come alive. And I'm always like, what's alive? I finally got this dead hunk of, circuit boards and sheet metal and other stuff. Bring it back from the dead or energize it. Anyway, paper tape and cards. Some of the jobs that I had to use mylar tape, which was much more durable than paper tape. Paper tape could tear, it didn't hold up to weld and moisture, all that kind of stuff. So I used mylar tape, which was much more expensive, and it took a terrible toll on the hole punching. You still had to punch holes into the paper tape, and that was what stored your program. Early language Fortran. That I was more off in the science and technology departments areas, so Fortran was the language of choice there. And large installations like the government, COBOL became the language that was most common and dominated. And I didn't realize that at the time, but later on I did run across that most large installations just used COBOL, and it was all written in COBOL, and it had become a problem because they had programs that had been written 5, 10, 15 years earlier, and while the person who had written the program was still there, it wasn't necessarily a problem if you needed to modify it or, you know, found an error in it. But when those people had left or retired or whatever, then it became a real big problem to try to maintain an existing program because programmers notoriously uh, do not put a lot of comments in their code about what this or that does, and it makes it difficult for someone else to step in and look at the code and try to figure out what they did. I had a job once, and I would get sold out. I worked for a company that basically I was, you know, white collar labor or something, and I would be sold on jobs. They would get a job, and I would be sent out there. So there was a job out in Arizona, and it was a particular airborne system, and the uh, the scientists who were trying to prove out a concept wanted the contractor to provide raw data of a certain thing when the programming in the airborne system was averaging it, or for example, or doing other mathematical operations on it before it was being shipped to the ground. Well, the scientists in charge wanted to see the raw data. Well, the contractor said no. I don't know reason why that was. Maybe they didn't know where it was either in the code at that point. I don't know. I think it probably would have highlighted there was a lot of errors occurring, and something needed fixing. And I expect the scientists had surmised that out of the data that they were getting down that was summed or averaged or totaled. But the contractor who was building the system said no. So I was brought in and said, we want you to edit this code so it will send down the raw data results. So I'm given this, the other thing, programs were printed out at the time. That was you took your card deck or your punch tape and you had to take it somewhere and get it read and printed out and form. And so you'd have these huge, they were 10 inches wide paper. I don't know what it was. Maybe it was the size of 8.5 inches wide paper, but I think I remember being like legal size paper. And you could have a stack like this tall, this tall, and you had to put a binder around it. And anyway, they gave me the code for this particular problem, and you know, uh, it's not commented. It's just a lot of code, and I don't remember the language it was written in. Probably, again, languages. There were a whole bunch of computer languages. One of them I had to play with was called machine language, and that was basically when a CPU was developed. The chip designers, the circuit designers, they would uh, right above the actual hardware level, they would say, okay, well, if you put this in, instruction, I'll do this or that. The computer will do this or that for you. And that was really primitive. Like, you would tell the computer, go out to a memory and fetch this address, the contents of this address, a specific cell of memory. Bring it into the computer. You would now have it in to a short little memory hunk that the CPU could actually operate on. It would add or subtract, or it would shift to the left or the right, or you could do other things with it. But that was really low level stuff, and everything had to be done. That's like walking, or take some simple mechanical task. It all had to be defined. I mean, every single thing, put fingers on cap, left finger, right finger, whatever. Uh, Now, turn left finger, turn right finger, turn right, to get a cap off a bottle. To do anything took lots and lots and lots of machine level code to get it done. And you had to know a lot about the specific CPU that you were working with and what instructions were allowed by it at that level. And that was machine language code. And there were not that many programmers, whatever coders, whatever the word is, who could do that. And because it varied by the manufacturer of the particular computer system and the CPU. At that time, we didn't have CPUs on chips. Intel came out with a 4040 back in 70, whatever it was. That was the first time the actual CPU implementation was put on a single chip. Before that, it was all discrete logic as to what a central processing unit did. And again, it brought a single something into memory, you did something with it, shifted the bits left to right, and then you would put it back out and you had to tell it where to store it into memory, which, or if you didn't have memory, you'd have to put it back out to magnetic tape or in some other form. Anyway, I'm mixing up all these languages, but you get the idea that early on it was, you know, and you would see ads in newspaper. I want a COBOL programmer with 15 years experience, in administrative and accounting software. Or you would want a machine language programmer for uh, Exxon's new 4465 CPU, which Exxon did actually move into the computer industry for a while, and they had some stuff like that, or there was an explosion of people building computers at the time, and many computers I got coming along, and there were several major giants and lots of minor players, and they allowed smaller companies and organizations to own a computer, which was important, hopefully, in the development of their business. Even small companies could do some accounting if they had the proper programming. And sometimes there was companies who built programs like beer distributors, or simple bookkeeping programs that were built by somebody and then offered up for sale or provided with a mini computer. So they began to creep into everything, even, like medium-sized businesses. No, they couldn't afford a giant IBM mainframe or COBOL programmers or even off-the-shelf programs that did that stuff, but they could buy a mini computer or a smaller computer and still a bunch of money, but they could get it that way. Okay, so there was changes in the hardware going on all the time. There was changes in development of higher level languages, so you didn't have to do it down at the machine language level, and a lot of changes in storage. Again, mag tape, punch cards, mylar tape, reel-to-reel tape. Uh, they were a lot of evolution and technology evolution going on at the time, and so things are changing rapidly. Uh, Early on, I had to do punch cards and magnetic tape, or yeah, store stuff to magnetic tape, and I had very little memory to play with. Most various projects, scientific in nature, especially for military or other applications. It might be off in a aircraft or on a ship or something like that. I had 5 kilobytes of memory to use for a program, which was more than just, it had to do some things. It wasn't just say hello, on the teletype that it was attached to. And by the way, that's how you had to use either punch card typewriter sort of thing that punched the card as you typed, or on the you had a teletype interface to a card puncher machine. You know, that was it. There was no screens, no video screens. Now, I did have jobs where there was a mainframe, and they had gotten to the point where they were tying computer terminals to a mainframe, so you actually had a screen and a keyboard. Before that, it was teletype. Uh, Early on, I had to work for companies who were science, in Orient, and they had bought timeshare. There were what's called timeshare computers, and that was prevalent. Somebody had a big mainframe someplace, and you could pay them, and then you got a teletype system in your facility, and over a modem. That's how it worked. Over the modem, you could get access to this timeshare, and uh, uh, you had an account there, and so you could type in a program, and it would store it at the other end, and you could edit it, uh, print it out, and edit it, and then eventually you could start trying to run the program on the remote computer, and it could be anywhere, and it would print out the results of whatever you programmed for. So timeshare computers were around at the time, and it was all teletype. I got stuck in a closet out at Wright-Patterson Air Force Base one time, fixing something for them, and they gave me a closet with a teletype machine into it that was linked to their main computer. I had no screen. It was nothing like that was available. It was a teletype machine. And so, I had to type in the program and run it and edit it and print it out, get it printed out, and go pick it up and from the service desk. And that was really a nightmare. And your productivity is fairly low when you're doing something like that because there's so many, manual steps involved. There was a lot of, punch the deck, take it to and I'd seen people, that you maybe have 500 cards in a program. punch cards. And somebody's carrying them in a cardboard box and they drop them. Now they're out of order. That was one of the things you could do when you punched the card. Not everybody did, but they put a number on the card. They like, this is number 53 of 5,000 or whatever. If you didn't have a number on the card, reassembling that card deck was going to be a nightmare. If you had a printout of your program, you could repunch all the cards and put them in the right order. But I saw that happen. It never happened to me, but and in the realm of paper tape or mylar tape, I tended to keep programs in hunks. It was easier to load it, if you only had 20 feet of program to load as opposed to 300 yards of program. And if it was all one program, then every time you printed it out, you had 300 yards of tape. So I divided it up into smaller chunks, and therefore I had to keep those chunks in a particular order. I had to be numbered, labeled, whatever. This chunk, then this chunk, and then this chunk. So there was a lot of steps in the process. So your productivity was fairly low. It was just hindered by the mechanics of what you were trying to do. And when screens and actual keyboards came along, that really helped a lot. But that took a while. I was still doing stuff for the man and whatever they had sold me into doing. And it became obvious that I needed my own computer at home, and so I don't know. I was probably one of the first 10,000 or 20,000. I don't know way of really knowing to get an IBM PC, personal computer at my home with a monochrome display and dual floppies, and I think it cost me like $5,000, which was a whole lot of money at the time. But with a modem, I could tie on to a remote computer, a timeshare computer, the computer I was allowed to get into, and write code at home and have it run on that remote computer. So I did need one, and I had one early on. And those days, DOS was the operating system. You had a command line. When your computer came up, it would have a command line. What do you want me to do? And you had to know the commands that DOS allowed you to use, okay? Read from this file from a floppy disk, or write this file, or even create a file. It was all very labor intensive, and you had to know a lot of commands and whatever. I eventually, of course, upgraded to a hard drive, and that was a big whoop. I think I got 10 megabytes of hard disk space for like $300 at the time. So I didn't have to use floppy drives. In fact, what I did was I got rid of one of the dual floppy drives and put in this hard drive, but I still needed the floppy to take any kind of program I had someplace else. That was the only way, to do anything. Okay? This is going on too long. It was a whole lot at the time. The technology just wasn't there, and people did accomplish creating new programs to do things, but it was very labor intensive and lots of steps involved. Um, uh, uh, Fortunately, I did learn several other languages over the period of time. Anytime I got sold someplace, I could walk in and find that all the code had been written in some other language. Okay, so now you had to, come up to speed on that language. But they were all basically same. All of the programming languages are the same. They basically consist of nouns and verbs. You name something, this is what this means, this is this object, and then what do you want to do to it? You add, subtract, multiply, divide. You store it, you retrieve it. It's not that different between all programming languages. Now, when I take a look at languages that are used on the internet today, um, they don't seem as high level as I thought they should be. At this point in time, you still have to do, screen definition here and there and define the boundaries and all this stuff that I thought it would be a little bit beyond that point, to be honest with you. I did what was called some object-oriented programming, which I thought everything was headed to, and it probably is underneath everything. And that was an interesting concept. One of the problems with programming is that it seemed like everything had to be written over and over and over again. Now, over time, like the operating system, once you got with your computer, there were various functions built in. And early on, no. For example, if I needed the value of a cosine at a particular angle, the operating system didn't have anything that did that for you. You would have to write your own sort of cosine program so you could give it an angle and back would come an answer in radians or whatever it was that you were using, okay? Um, but over time, the operating system, they realized, like random number generators, I really want to have to write the code to use a random number generator, and so they started building things in. However, there was still lots and lots of routines, like in the mainframe COBOL world, that were used, all the time, the same sort of stuff. It was doing the same thing over and over again. But when you wrote a new program, there was very little reuse of old modules, code. It was a crime to have to rewrite the same code over and over again. And so more and more was pulled into the operating system, provided you at relative, basic functions. That's what it was. Not something unique to a particular domain like accounting or, signal processing or something like that. Okay, so the idea of objects came up, particularly I think out of the visual world when we started moving over to screens and keyboards. Early on, there was no mouse. The screen stuff was mainly just reading it. You weren't interacting a whole lot with the screen, other than entering commands through whatever user interface was provided by that particular operating system. Okay. Uh, anyway, object-oriented programming came around, and they said, okay, well, like something on the screen, an icon. You know, they, if you think about it, on your PC, you got all these icons, and when you click on it, it does something. Well, the creation of an icon is an object, and so if you created the code that said create this thing on the screen, a box, a circle, a square, or whatever, it should have sort of the same attributes. You can define, what it looks like and the color it is, all those things. The basic program to develop an icon. And all you had to do then was to tell it I wanted it to be this big, I want it to be this color, and I want it to do this when it gets clicked. But you didn't have to write the code to draw a box on the screen and color, and you didn't have to actually put the code for what you wanted that button to do inside that button. You could tell it to go here or there. That was object. That was an object. There were all sorts of different kinds of objects. That came along, what did not exist early on at all. And it was more an outgrowth of the visual, screens, keyboards, that sort of thing. Uh, I'm so old that um, I don't know where to go from here. I played with databases for a while, and that's an interesting world. And databases, large accumulation of data in some organized fashion. Now, in programming, I often had to create tables. Data. I mean, what's the point of a programming if it's not processing some sort of data, either in real time A sensor is providing you data, and you're doing something with it mathematically, and and then but you need to store that results, and that's data. And if you didn't have, if you had real tape, you could write it out to there, or if you had a floppy disk, you could write your data out to there, and it would store it. Okay, but there was often times that you needed that data in close proximity, so you could store it in memory if you had enough memory. And it was often you would program a I forget what it's called now, a stack, a lattice, rows and columns of data that you could tell, I want the data out of this column and this row, and you could operate on it. And that was okay for little stuff, only this much data. But then you start getting big reams of data, like inventory for Home Depot. They must have, 40,000 items, or I don't know what they have, 100,000 items that they regularly buy and sell. So you had massive amounts of information, and what came along, you got to store it. Yeah, but then how do you update it, change it, add to it, retrieve from it, modify it, all that. So databases come along, and Oracle. Now everybody, well, not everybody knows Oracle, but they were one of the first pioneers to provide a database. It was really just massive program, but it had high level sort of instructions on how to play with that data. You didn't have to necessarily go down at a low level and putz around telling it, you know. You had ways, high level ways of organizing the data, retrieving it, combining pieces of data together to create new sort of data, if you will. I need to know not only the zip code but his name. I would, combinations of data would be presented, could be created out of massive data. And Oracle was one of the ones who had high level, and they provided some, like I mentioned early on. There were the additions of high level functions were added into operating systems as time went by, and databases, they started providing high level things like they were a join command. You could take two databases and join them together and create a new database that had all of the elements that you needed for, like, you had a database of a name over here with all associated data, and you had a database over here of zip codes, but it had names in it as well. So you'd want to join those two together to be able to play with name and zip code or other combinations. They provided commands that allowed you to do that relatively easily, as opposed to having to do it at a brute force. You doing it, recreating the code every time. When I was around early on, they didn't have any high-level codes, so you had to do it all yourself. And very early, Fortran, for instance, allowed you to create what was called subroutines, and that was hunks of code that you would use over and over and over again, and you didn't have to just write that same code throughout a program. You could write it once, and then when you got to the point where I need to do this particular dummy little function, you could call up that subroutine, tell it what the parameters were, it would do it, spit back the results, and you go ahead. So part of programming at that time was figuring out what hunks of code belonged in subroutines so you didn't have to rewrite them. And that would evolve over time. You'd start off, you didn't really realize that you were going to be doing this over and over again. It's hard to see the whole thing in one big hunk. So it would take a while. Okay? I don't know. This might not even get posted. It's so long and hairy and weird. But there was a whole evolution going on. And when I first started off in 1969, 70, 71, I think I read someplace there were about 10,000 what you call programmers in the United States. And probably the bulk of those were at the big companies and in the government playing with COBOL. Much smaller number were in the scientific arena and working for Department of Defense or some contractor. Medical, it depended. Military is always good on spending money on stuff and trying to improve their products. So they're always in the lead on that sort of stuff because they have unlimited money coming out of the taxpayer. So they could try to implement something using a computer that had never been done before, or computerizing a process, or upgrading it, getting more capabilities. The military was very good at that. They didn't waste money. They were always trying to, they had a concept. And they were trying to see if it was valid or not, and they would buy the equipment and hire the talent. So I was one of the probably 3,000, 4,000 programmers at the time who dealt with the scientific community, scientific applications, and the computers that were available at the time, and they weren't much, especially in what was known as the rugged environment on a ship, in an aircraft, that kind of thing. Um, After a while, more programmers came online, and I was involved in hiring a couple. And it was funny. I didn't realize programmers have to really think about well, what could happen, especially when you have user input. Now, early on in scientific stuff, I would generally know the boundaries of the input data. It can't, like temperature. Okay, there's a range. Well, the lower end is set anyway. Higher end, yeah, it's not going to get whatever I'm dealing with. It's not going to get to 40 million Kelvin degrees hot. You know, but there could be an upper limit. But the lower limit is usually known. So the program that you wrote, the code that you wrote, it had to be able to accept inputs in a certain range. Now, when the user, Harry homeowner got his computer and they started selling applications and whatever, the programmer better remember or build into his code that when it says, well, how many feet are you talking about? And it said he typed in 400 million. That would be out of the bounds, and his program, if he tried to take that, would crash. There was a case I had to go out and fix a program somebody else had written, and it was all three-dimensional geometry. And the guy who wrote the program, he's smart as hell. He just wasn't a programmer, and he forgot that when you try to give cosines and sines and all that stuff can go through zero. The answer comes back that given this angle, 360, 180, the answer is zero. Well, he routinely would have a cosine or a sine or some other trigonometric function dividing something by that sine, that trigonometric function. And when the divisor went to zero, it would evaluate as infinite, and that code didn't like it. That the next the next piece of code says, well, what am I supposed to do with it? It's undefined. It created an error right there. I can't deal with infinity. I don't know what to do with that. So he knew his stuff, but he didn't know programming, and that you have to think outside that. Well, when I hired people, I quickly learned that I don't know what it was. Some people just couldn't think about all the possibilities that may happen in the particular situation that you're programming for. And, it always occurred to me, what are the boundary limits of the inputs? Or when I started writing code for users where, they could put any number in, or they could, this or that, or give me a name. And I had to realize that they often go outside the bounds. They made a mistake. They put too big a number in or too little a number or whatever it was. It wasn't, accurate. It wasn't viable input, but they put it in anyway. And the program had to be able to recognize that and say, no, you can't, you can't do that. And here's the reason. Uh, I was always one who documented my code. Most programmers did not. And I find if I didn't document it 2, 3, 4, 5 years later, if I picked that code up without documentation that I had written, I would have difficulty sorting out what all it was doing. And that took extra effort to document it, but there were instances of the code that I wrote, even 6, 7 years later, somebody else could come in. They did come in, and they were able to sort out some of the more intricate processing routines, mathematical routines that were done on signals or whatever. And because I had documented it, they could figure it out and upgrade it, move it to another language, move it into another computer. So I documented heavily. I doubt seriously the people who called coders today do any much documentation at all. They just want to get it done and move on. So the life of that code may not be very long, and maybe that's true for all code today. The code I wrote back in those days, in most code, it had a life to it. Could be fairly long, years and years. Um, the scientific programs that I told you about, like Naval Research Laboratory, proving a concept of something, they used that code for a long time. And if it proved, they could prove that, yeah, the concept appears to be valid, they could get some more money for the next level up, and they would upgrade their hardware and they would rewrite it in a different language, or they might expand the code. Um, but they had to use, they had already expended this money for this, so they wanted to use it for the next level up. Um, Paper tape, punch cards, teletype machines, floppy disks, uh, various languages, all kind of different languages. Those are the areas. That's how I grew up in this stuff, and I also had developed a bunch of hardware, and I don't even want to get into that. But uh, and I've preached this before, and it is a preach. If you want to be valuable to other people, you need to have multiple skill sets. And so when I was doing hardware, I realized the future was going to be software. There were very few hardware designers around at the time, and that was all great. But with the invent of CPU on a chip, and chips becoming more and more complex, and you could even define how, put all this whole circuit on a custom chip if you want. Software was the way to go, and I moved over to software, but I still had a hardware background. So now there were jobs that came down the pike where you had to be able to do both. I need to design a board that goes into this piece of equipment and then write the code that works with that piece board that you just designed and be able to get data into and out of it into a computer that then you do this and that to it. So I had multiple skill sets, hardware and software, usually at a very primitive level, way down in the dirty level of computers, not up at the high level where you're writing, a program just for the chief operating officer of a company. He only wants to look at this now and then. Early on, we had secretaries. So if I wrote documentation for a particular project I was on, I would have to write it by hand, give it to the secretary, who then typed it up, gave it back to me to proofread and edit. What a terrible time wasting experience that was. And I was not a great writer, and so I would have to do a lot of edits, and it took a long time to get a technical document created. Okay. Well, over time, of course, word processors came in, and that helped a lot. Still had secretaries, still hand wrote documentation, gave them to them. They typed it up, returned it to me, and I would eventually prove it, and it would get sent on to the client or put in the archive or classified or whatever it was. Eventually, we moved over to word processing, and the guy that had that terminal on his desk doing whatever he was doing became his own You had to learn word processing. In fact, most people with computers know word processing and they know how to do spreadsheets. And that was once done by somebody else, a secretary. Uh, Spreadsheets, I don't know who did that early on for people, but somebody did who specialized in that. But now, word processing. I'm sure there's executives that don't do their own word processing. They may do their own emails now, but they don't write a whole lot of big documents themselves. They still have secretaries that do that, and perhaps they do it in dictation. He rambles and she records it and then listens back and types it all out for him. Anyway, this is way too long. I'm just trying to give a thumbnail of the world that existed at one time and it doesn't anymore. Sometimes I'll give a view of what, sometime maybe I'll give a view of what the future looks like in computing and artificial intelligence, machine learning, all that kind of stuff. And from my background, where I think it might go or not go, or the limitations of it. Anyway, this is really too long, and I'm just waiting for the temperature to warm up outside so I can go move around some more dirt and rocks and, get grounded again in something real. I forgot this is episode whatever, but I'll put the right label on it when I post it. I hope you got something out of it from an historical context. Uh, uh, Primitive, very, very, very primitive compared to today. And it was one last note. It was interesting. You used to be able to go out to lunch. This was years ago. You used to be able to go out to lunch and classified projects, whatever we're doing. But you could talk to somebody else about this stuff, and nobody else in the room even knew what the hell you were talking about. I had to do this and that and that and this. Nobody knew nothing around you. They didn't. You could talk about it openly, and it wasn't a person. Now, with cell phones and everybody's got some little, and I mean a little bit of knowledge about computers and they know the term operating system and things like that. You're more limited in what you can say in public, but nonetheless, it would be easy to take it to a level that nobody's going to understand. I always thought that was funny. It got to be amazing when I did go places and I would just be sitting there and I could hear conversations about some programmer was talking about a program he had written, or they were talking about solving a problem that they had, and I could understand it. There were other people out there now where it had only been me or a couple people. There were a lot of people now. The point that I could run into them. Now I lived in the area, Washington D.C. area, and there was a lot of programming and a lot of computerized stuff in that area. If you live in Boise, Idaho, not so much. You know, that was part of the deal. I lived near the government. The government spent a lot of money. They had a lot of computers in the government at all levels, from the high level Census Bureau all the way down to the Department of Defense or even Department of Agriculture. They played around with computers. So enough for today. I I think I'm approaching 1 hour, which will be a new record for me. Happy birthday to whoever, and this is the end of this episode, never to be seen or watched again by anybody.